Okay, today I'm recording this in retrospect. Um, I worked um, on a vehicle at the garage 2 days ago. I believe it was a 2001 model year Toyota Progres with a 1JZ GE engine. It's a 2.5 inline um, 6-cylinder engine. Had automatic transmission, I think. Um, it has a few bells and whistles. It's that in the Toyota lineup, that vehicle is comparable, very much comparable to a Mercedes C-Class or a BMW 3 Series from the same generation. Anyway, the issue with this vehicle, it had a bit of history. Um, it wasn't running right. The engine wasn't running right when it came to the garage. It had misfires, low power, um, backfires. Generally, the engine was not behaving right. Ivan dealt with it before me. He found a few things. He found some things which looked bad, and he went rectifying those as he found them. I think most prominently was a bad fuel pump, very dirty fuel filter. I think spark plugs were bad as well because, in fact, it had a United Nations kind of arrangement with the spark plugs because out of the 6 spark plugs, I think they came from 4 different brands. Maybe there was one from a brand or make each, and then maybe two pairs from 2 different brands of spark plugs, that kind of thing. You understand what I mean? Anyway, the vehicle improved, but it improved. It was running well, seemingly well at idle, and it had it ran very well at idle, both at idle and with increased RPM when it was cold, and when it got hot or when the engine got heat soaked, it would start misfiring again. That's when I had a look at it, and the image I have on the screen for you, I've already set it up, is because after extensively going over the injectors and finding injector number 3 to be of a slightly different resistance to the others, but finding that the current and even the spray pattern, I tested the spray patterns, they all seem to be similar. I couldn't measure fuel pressure on this system, but I believed it was fine because when the engine runs fine, it does run fine. And if there is a problem with the fuel pressure, it would be obvious, especially when it is when the engine is cold. That's when you'd really check out a bad fuel pump. But this fuel pump seems to be working fine, just because the vehicle for the most part ran quite well. The engine ran quite well when it was cold. So I recognize that the resistance on one of the injectors, specifically for cylinder number 3, was slightly like 0.5 ohms different from all the others, which were exactly which matched. I think it was something like 12.6 ohms for the good injectors. This what looked like a the odd man out had something like 11.9 or something ohms. Anyway, I ignored that, especially because the current, when I paraded the current ramps, they looked quite similar. And when I checked the spray patterns, it was good. None of the injectors seemed to be leaking. So I went away from that. And also I did, because the scan tool allowed me to disable one injector by one. It felt as though they all responded in a similar fashion, so I couldn't really pick any which seemed to be weaker. And so I went to ignition next. I was very sure compression is fine because, once again, engine runs very fine when it's cold. So obviously, we are probably dealing with an electrical issue which is magnified or which manifests itself more when the engine is hot. And the only other thing that could behave like that is sometimes a vacuum leak, but then a vacuum leak would affect all the cylinders in the same way, so you'd end up, I don't think you'd end up with such a misfire. And in any case, I checked the fuel trims, although they looked a bit negative, like -8 for the long term, and like almost 0 for the short term. I couldn't, at the different RPMs, I couldn't really point at a vacuum leak. So I went away from that. Oh, by the way, this vehicle was a speed density engine, so that behaves, the fuel trims would behave a little bit differently with a vacuum leak. With a mass airflow system, they would be quite positive and then go then smoothen out or correct as they would be negative at idle and then correct as the RPMs increase. With this one, because it's a speed density system, it would be a little bit negative. That's why at some point I also suspected the engine may have a small vacuum leak, but that didn't play around with the fuel trim, so I went away from that and came to the ignition coils now. And I also checked the timing, ignition timing, again using the oscilloscope. Unfortunately, I didn't record all this because I didn't think it was going to turn out into such an extensive case, an extensive investigation, and also it was very hot and shiny that day. I was getting tired, and also I would have had a lot of glare working with the laptop. So I didn't shoot from the beginning. Anyway, I'm telling you what I did. Take my word for it. I did all that. Checked ignition timing. It looked fine. I used our coil on plug tester for that, as well as the high amp probe and the oscilloscope, as I normally do if you've seen my previous videos. So I then arrived at the ignition coils. Now I have the circuit for the ignition, spark ignition system or circuit for that particular vehicle, the 1JZ GE. It's a Toyota engine, it's a 2.5 liter. Now, what I did was to go to wire number 3, which is this one, the ground, and put the low amp probe on it and viewed the waveforms on it. When I go on this wire, this vehicle has an engine control module, which is here. It has the ignition coils here. I remember I said it's a straight 6-cylinder engine. All the 6 cylinders are in a straight line, and you notice it only has 3 coils, ignition coils, because it uses a waste spark system. Each ignition coil fires 2 spark plugs, and so when I put my amp probe around this wire, I'm expecting to see the current drawn by all the 3 cylinders at the same time. In other words, I'm parading the current ramps from all the 3 cylinders because I wanted to see very quickly if there was an issue. And indeed there was, as I'm going to show you. Coil number 2, which is this one, I found that out later by first of all, I paraded the current ramps from the 3 coils, and then when I noticed that one of them was acting up, one of them had an issue, as I'm going to explain to you, to find out which coil exactly was the one with the issue, I put our coil on plug detector on coil number 1, which was the easiest to reach. And by the way, the reason why I chose to go on this wire is because this igniter control module is ignition, rather, let's call it the igniter as they've called it here in the picture, is very, very accessible. So I didn't even bother going this way toward the engine, which was hot. I started by connecting to this wire, which was very, very convenient for me to do. And then, as I said, I put the coil on plug detector on coil number 1 to be able to identify which of the coils was acting up. The moment I detected, I discovered one of the coils was shorted out. So I was on this wire, and I will show you what I saw. Actually, I'm going to pause here so that because when I was shooting this toward the end, it got dark, and that's when I remembered to pull the camera out because it was very interesting what I found. I wanted to share it with you, and I'm going to pause here and show you a minute or 2 of footage I shot live with the oscilloscope of what was going on, and then we shall come back and I explain the waveforms and what they mean. Tirako njagala katumyawo wano. Kaina mukuwoninga low battery muka. Njambaza wano. Okay, nzirizaako gundi eri coil on plug. On the first coil. This so we have a coil here. Okay, now here is an explanation of what I found. I think I may have this the right way up. This is the current ramp, but it is inverted. Let me see, because I took a few screenshots of it. I do remember at one point when I was working that I did press the invert button and had the current ramp, these ones, the right way up. Anyway, it doesn't make much difference. What you need to know is that these ramps that are going down, they should be inverted. They should be to understand this much easier, is they should be the right way up. But what you need to know is, what is important is the magnitude and the shape of the ramp, not the direction in which they are facing, in this case down. When they are pointing up, it's easier for anyone to visualize, but I'm sure you can visualize this. You have every time a coil is fired, it consumes power, and a good coil should have a ramp like this or that, because current builds up. Remember, this is inverted, so this is current building up, reaches a peak, then falls down. I couldn't expand the time base so much without losing the pattern, the parade, because I wanted to see all three of them repeated. So I had to compress the time base a bit. That's why the ramps are not so obvious, but they are there, you can see them. But you agree with me that these two, which is what a good one is supposed to look like, look very different from this one, and the pattern is repeated. So that means, because there are three coils which are paraded on the same ground wire, because they are sharing it, you can see very clearly that one of these coils is shorted. So every time the igniter grounds that coil, or attempts to ground that coil, the current goes up, straight up, shoots straight up, and then the only good thing is this would lead to a blown fuse, but the igniter circuitry has a way of limiting current, so it would limit the current to that level, similar to all these other two, and then the event of creating the spark will disappear. Now, I also hope you have noticed that we have a spark here. You have another spark happening, and that's because the coil on plug item, rather detector, we have one, and we could only place it on one coil at a time. So we detect ignition spark on the coil to which the COP detector is attached. Then we have a missing event here, because now it is these other spark or coils which are firing, and then when it is repeated on this one, we see it lining up with the current event. So this is for synchronizing. So clearly we could see, because they were firing in this order, this was cylinder number 1, rather, forgive me, coil number 1, this is 2, this is 3, 1 again, 2, and the process repeats. So I used this to synchronize because I knew this was on cylinder number 1, I knew that, and this was the current ramp. So coil number 1 was good, and the one that fires before it is this one, that's number 3. So this was number 2. So from that I could tell that coil number 2 was the issue. In fact, I did go back, if I can show you this image again, to prove that it was coil number 2 that was the issue. I did go to the control wire from the igniter going to coil number 2, and I put the amp probe around it, and it was now we could still see this portion. We could still see this kind of shape of the waveform, but this time without these other two, because remember now I was on just the control wire for that one coil. This was when I was on the ground for all of them, so I could parade and see all of them. So basically we had a shorted coil on that vehicle, and the reason why I've shot this in retrospect is to share with you a tip for using the amp probe, low amp probe with oscilloscope to see a problem like this. It was quite difficult to see this without an oscilloscope, because when we took the bad coil off the vehicle, we tried to measure its resistance compared with the good ones. Believe you me, the good coils had, I think, something like 0.9 ohms. The bad one had 0.6, I think, 0.6, or they're about 0.6 now. Especially because you are not very, most of the multimeters that we use as ohmmeters are not the real expensive ones. You can't even, if you are just checking these coils on looking just at the at the resistance in the coils, you would have been fooled. And we managed to repeat this test when the coil was off the vehicle after a while. Believe you me, it also read 0.9 ohms just like the others. So the issue was, every time this coil got hot, if you have it on your desk, if you take it off the vehicle and test it on your desk using simple multimeter, it would show you readings similar to a good one. But the moment it was on the vehicle and got hot, it started shorting up, and the only way to see it is when it is in action on the vehicle, and clearly it was shorting out, as you can see. That was the diagnosis. Thank you for sharing. I want to thank some of the subscribers for our channel and the on the group page, Facebook group page, for Talk to Micah, for sharing our videos and our page. And recently we are getting an average of about 5 new members to the group page. So I thank everyone very much, and that has been going on for about 2 weeks. I'm not very sure how that happened, because it's been a while. We've not been getting so many members joining the group, but recently something seems to be happening. If you're one of those participating in spreading our gospel, thank you very much for that, and thank you for watching this video. Bye.